So do not worry, they're making recordings for everything. Okay. Yes. So the next part, we need to calculate the coefficient of variation for A and B. For this coefficient of variation, you're just seeing the trade-off of risk and return. It just tells you for every 1% return that you get, what percentage of risk are you taking? Okay, that's what coefficient of variation is telling you. For every 1% return that you make, how much risk are you taking? So the coefficient of variation is just the standard deviation divided by the expected return. Okay. So for investment A, expected return 10%, standard deviation 0.052. Okay. So once we get our coefficient of variation, okay. So coefficient of variation, standard deviation divided by expected return, you get 0.52. Okay, 0.52. Okay. So for every 1% return, there is 0.52% risk for investment A. Okay? For every 1% return, there is 0.52% risk. We go to investment B. The return, expected return for investment B is 0.127, 12.7%. The standard deviation, which is the risk, 0.162. Okay. Coefficient of variation, standard deviation divided by expected return, 1.27. So for every 1% return, there is 1.27% risk. Okay. For every 1% return, there is 1.27% risk. So there is more risk attached for every return that you get. Okay? So you would label investment B as a risky investment because the risk exceeds the return. Okay? Any questions?
This other one, the bottom one, is supposed to be P.
That is the coefficient of variation. Are there any questions before we now move to now here 1, 2 and 3 we are dealing with the investments individually. Now we're going to start taking this as a portfolio. Okay. Remember, a portfolio is a group of investments. The purpose of making a portfolio is to diversify risk. Don't put your eggs in one basket. Okay? Yes. So now let's say calculate the return on the portfolio if you invest 8 million in A and 12 million in B. Okay? So this is how you get the expected return for a portfolio. The weightage of stock A multiplied by the expected return of stock A plus the weightage of stock B multiplied by the expected return of stock B. Weightages were just saying out of the total money we've invested, how much have we invested in A and B? That's what the weightage is telling us. Okay? A we invested 8 million, B 12 million. So in total we invested 20 million. Out of this 20 million, we'll say, what percentage is investment A? So you're going to say 8 million divided by 20 million. You get 0.4. Okay? 8 million divided by 20 million, 0.4, which is 40%. Okay. Investment B, the weightage, you're just going to say 12 million divided by 20 million, 0.6, 60%. So what these weightages are telling us is that investment B is going to have more of an influence on the expected return of the portfolio because it's got a higher weightage. Just like your grades, okay? Assignments, quizzes, and tests, they've got a lower weightage. Your exam has got a higher weightage. So your overall result is going to be mostly influenced by your exam because your exam has got a higher weightage. I don't know if it's still 60%, then CA is 40%. So your exam has got a bigger influence on your grade. Now we take it back to here with these investments here. Here investment B is going to have more influence on the expected return because it's got a higher weightage. Okay. So these weightages you multiply by the expected returns. Okay. Expected return was for A was 0.1. So it says 0.4 times 0.1, 0.04. For B, 0.6 multiplied by 0.127, 0.0762. Okay, then you just add them. 0.04 plus 0.0762, you get 11.62, which is same as a return of 11.62%. So if you invest in both A and B, and you made a portfolio of them, your expected return is 11.62%. Any questions? Okay. Calculate the risk on the portfolio. Okay. Now we're calculating the risk on the portfolio. Now here, it's not, this is the formula for the risk of the portfolio. Let me just put it in simple language first. English, what this is saying here, this formula in English, okay, because it's in Greek, this is in Greek here, okay, but let me translate it into English. This W here, it is the weightage, so here we are dealing with investment A and B, so I'll put here A, weightage of A multiplied by the variance. This sigma squared is the variance of A plus weightage of B multiplied by, oh, and they are squared, so weightage of A squared. This variance is just like the standard deviation squared, okay, colleagues? Variance is the standard deviation squared. And we already calculated it when we are getting the standard deviations for each of the portfolios, okay? Weightage of B squared multiplied by variance plus 2 multiplied by the weightage of A, 2 multiplied by the weightage of A multiplied by weightage of B multiplied by the covariance. Okay, colleagues, this is in English, in simple English, this is what we're going to get the risk of the standard deviation of the portfolio. So what is this covariance? Okay, covariance basically is showing the relationship between two investments. Okay, how two investments move in relation to each other. Now this is a very important aspect of portfolios, okay? Because as we said, if whenever you're making a portfolio, you're trying to diversify your risk. Okay, so you want to get individual investments that move in opposite directions in relation to each other. Why is this the case? So that should one investment do bad, the other one will do well, because they're moving in opposite directions. Okay? So that if you have a rainy day, at least one investment A does bad, investment B should also do better. Now the covariance is the same, meaning they move in the same direction. Okay. If one investment does well, the other one also do well. That will be a plus on your side. But the disadvantage is if one does bad, the other one also do bad. Okay. So when you're forming a portfolio, you want your investments to move in opposite directions. Okay. Negative covariance. Okay, so that in case things go bad that year, if one investment doesn't do well, this the other one should do better. Okay, colleagues? Yes. So a positive covariance, the investments move in relation to each other. A negative, they move opposite each other. Okay? A zero covariance, there is no clear relationship. Okay? So this is how you get the covariance. The probability multiplied by return return of A multiplied by the expected return of A multiplied by the return of B minus the expected return of B. Okay. These are, remember, these are the deviations we're calculating earlier on. So, first things first, let's get our covariance so that we deal with the heavy lifting for this formula. Okay. So for the covariance, this is the table here. Okay. As I'm doing my workings, you'll see here. Okay. So remember, you're subtracting each return minus the expected return. For investment A, when the economy is in a boom, the return is 20%. 20% minus the expected return of 10%. Just the way we're getting the deviations earlier on is the same thing we're doing here. Okay? Each return minus the expected return. Okay? Each return minus the expected return. Each return minus the expected return. Okay? Similar what we're doing when we're getting the standard deviation. The only difference is this time we're not going to square these deviations. We'll leave them as they are. Okay? Even for investment B, we do the same thing. Each return minus the expected return. Each return minus the expected return. Okay. This is the first part we've done. Each return here for investment A, each return minus expected return. For investment B, each return minus expected return. So basically these are the deviations. So these deviations we're multiplying by the probability. Okay? So let me put here. So here we're going to say the probability of a boom 0.15 multiplied by the deviation for A multiplied by the deviation for B. Okay. We continue. Probability multiplied by the deviation for A multiplied by the deviation for B. Probability multiplied by the deviation for A multiplied by the deviation for B. Probability multiplied by the deviation for A multiplied by the deviation for B. Okay. So that's what we've done here. We multiply the probabilities by each deviation. Then the last thing you do, you need to add. That's why this sigma is there, you need to add. Okay. 0.072, okay, which is like 7.2%. So now this is how we interpret this covariance here. This is 0.72, which is the same as 7.2%. So it means these investment A and investment B have a positive covariance. So what that's telling us is they tend to move in the same direction. If the economy is doing well, the financial markets are doing well, both will go up. If the economy is doing bad, both investments are going to go down. Okay? then this 7.2%, it's not a very strong relationship. Okay? The higher the percentage, the stronger the relationship. But here, since it's 7.2%, that's not a strong relationship between these two investments. Okay? Yes. Any questions? Now we can calculate the risk. Weightage squared for investment A. Remember, investment A, the weightage was 0.4. When we're calculating the expected return for investment A, because I have to show you where all these numbers are coming from. So I'll put the formula here. So we're going to start square root weightage, this W this W squared, that's the weightage for investment A, which is 0.4 squared. Multiplied by the variance for investment A. The variance for investment A, here it is variance. When we're calculating the individual standard deviations, okay. Or if you want, whatever standard deviation you have, just square it. Okay? So 0.00275. Zero point zero zero two seven five. Okay, colleagues. Plus weightage of investment B. Remember from here, weightage of investment B is 0.6. Squared multiplied by the variance of investment B. The variance of investment B, as we can see here, variance is 0.026. Okay. For this standard deviation, you can just square it. 0.162, you square it, you still get 0.026. 0.0262. Okay. Plus two times the weightage of A times the weightage of B. Weightage of A 0.4 multiplied by weightage of B, 0.6, multiplied by the covariance, which we got here, 0.072. Big tabulation. So start 0.4 squared, zero point 4 squared, 0.16, 0.16 multiplied by 0.00275, get 0.004, 0.00044 plus 0.6 squared multiplied by 0.260, 0.0262, we're going to get 0.0094, 0.0094 plus 2 times 0.4 multiplied by 0.6 multiplied by 0.072, 0.034. Okay, then we add 0.00044 plus 0.0094 plus 0.034. You get 0.043. So get what is the square root over 0.043. You get 0.207. Which is 20.7%. So this portfolio, 20.7%, has a risk of 20.7% standard deviation. Okay? So how, remember how we interpret this? The expected return of this portfolio is 11.62. So if we can make like a diagram here. Expected return of the portfolio 11.62%. 11. Just 11 plus 20. So I just get the numbers first. That is 31. 11 minus 20. Negative. Okay, I've just rounded off the numbers. I've just rounded off the 20% to 20 and the 11 just to So basic, this is the range where you might find your returns if you invest in both A and B. On average, expect to get 11.62%, but that's not guaranteed. You might get a return of 20%, you might get a return of negative 8% loss. The next year, you might get a return of maybe 12%. The other year, you get a return of negative 7%. So as you can see, these returns are jumping up and down, okay? Because there's a significant amount of risk. Network is not favoring you guys to hear. Yes. So the expected, the standard deviation, the risk